Hi, this is Victor Morganti from Fact Engine. I'd like to look at doing rapid keyword extraction from a document and rapid fact type extraction from a document to create an object role model, and we're going to do that inside the Boston conceptual modeling software. We're going to use two tools to do that. We're going to use OpenAI's GPT3 and a tool inside Boston that processes a structured and controlled natural language knowledge language to get a model, an object role model inside Boston. So we're going to use natural language from a document to create a conceptual model in conceptual modeling software. We've got the Boston conceptual modeling software open in front of us, and I've got a model open in the Model Explorer. It's a model I've called telephony, and if I look at the model dictionary for that model, it's got no object types, fact types or constraints in the object role model view. It's an empty model. It has a page, but the page is blank. So we've got a completely blank model, and we're going to create a object role model for telephony. Now I'm going to do that from a Wikipedia article. So if I go to Wikipedia and I'm looking at a page for cellular network, I'm going to just copy and paste documentation directly from Wikipedia into the OpenAI API playground, and where we're working with the text DaVinci 003 large language model inside that playground. So this is an artificial intelligence, or access to an artificial intelligence, where we're going to engage with a artificial intelligence model to extract keywords and fact types from text. So I'm just going to copy a little bit more of this this article. So you can imagine where you could actually automate some of this to extract information from a corpus of or corpora of documentation, and we've probably got enough to work with, and I'm just going to remove a little bit of the excess text. So we've got our text that we want to extract keywords, so we want to extract object types for object role modeling, and the way I'm going to do that is by using what's known as a prompt for a large language model, which is an instruction for the artificial intelligence as to what to do. And I'm saying pull out every keyword from the above, so from the text above, one per line, and where a keyword can be more than one word. Keywords are not instances or pronouns, but noun forms. So that's an instruction for the artificial intelligence what to do. Now I will say, and as a disclaimer, that OpenAI for GPT-3 don't use your data for training, but it is stored on their network for a period of time for security purposes. And if you have any issue whatsoever of sharing information with OpenAI, then this approach to doing keyword extraction is not for you. If, on the other hand, you're okay with parts of your documentation being shared with OpenAI and stored for a short period of time on their network, then this is a effective and a novel solution for doing keyword extraction. I'll say that you should familiarise yourself with the privacy and data privacy policies of OpenAI before you proceed. So let's go ahead and pull out the keywords from that document. So I'll just hit submit on that. Actually, just before I do that, I'm going to change the temperature to 0 and increase the maximum length, which is something I need to do. So I'm just going to hit submit. Now, all things going well, that's going to go away and analyze that document and return keywords. So for some reason it hasn't come back with anything, I'm just going to hit submit again. Now when it doesn't return anything, it's probably because I've got too much text for it to work with, and I'm not within my limits of 4,000 tokens working with the model. Okay, so we've got success. So we're returning a whole bunch of keywords there. Now some of those are probably instances rather than object types. So an instance, for instance, might be a person called Peter rather than the object type person. We'll forgive it at this stage, and I'm going to say find more, find more keywords. It's still going. Excuse me. Well, actually that might be enough keywords. So what I'm going to do, no, that's only a few, I want more. So find more keywords please. I'm going to submit that. Hopefully we'll get some more keywords come back, and it's coming back with a whole bunch more keywords. Right, that might be enough for us to work with to start with. So I'm just going to grab all those keywords. Now I've got another instance of GPT3 open here, and what I'm going to say is these are all keywords, colon, and then I've got some more prompts to do some processing on that. So I'm going to say now change the format of each keyword to Pascal case, and where Pascal case is a capital first letter and lowercase other letters. And so GPT-3 now has gone and changed all of those keywords to Pascal case, which is great. Now I want it to do some more processing on that. I'm going to say now return each keyword in its singular rather than its plural form. So we want, say for instance, reception characteristic rather than reception characteristics. I'm going to submit that. GPT-3 is going to change those to their singular form. That's great. And I'm going to do a little bit more processing on that. But before we do that, I'm going to just weed out anything that is quite obviously an instance rather than an object type. So a pager might be an object type, fleet might be an object type. Let's accept all those, and we're going to say now add the text is a concept after each keyword. So for instance, cellular map is a concept, and I'll explain why we're going to do that when it comes back. Great, so that's come back and done that. So for each of our keywords, we've got the keyword and is a concept written after that. Now, I've had to hit go a couple of times, so it might have doubled up on some of these. I'll just check. No, that looks okay. Right, so let's copy those. And we've got our keywords. And we're going to go back to Boston and open the FECL uploader, so the Fact Engine Knowledge Language uploader. So what we've effectively done is created knowledge language statements to load those keywords up into Boston. Now I'm going to hit go. There might be a few errors as it processes this. We'll work through the errors as it goes, but we might be lucky and it'll do it in one go. So I've got a syntax error there. I'll just get rid of that bracketed format. It's already processed all that, so I'm going to continue on. I've got another syntax error. We've got a duplicate. Get rid of those. We've got another duplicate. These might be all duplicates from here on in. Yeah. So I'm not going to waste any more time on those. So I had duplicates because I pressed submit a couple of times in the playground. Now if I go to the telephony model again, look at the model dictionary, refresh the model dictionary, we've got a whole bunch of general concepts. So we've loaded our general concepts into Boston. These aren't object types at this stage, so they're not entity types or value types or even objectified fact types. We can convert them at some stage. Well, some of them are going to be converted automatically, and we can convert them as we need to. Now I've got a configuration item in Boston where if I go to the Boston tab or the modeling tab, it says natural language API converts general concepts to entity types. So when we create our fact types, any used general concept will be converted to an entity type. So we'll see that in action in a second. So let's go back to GPT-3 now, and where we've got our keywords. Now if you just give me 1 second, I'll remove is a concept from these keywords. So I've just done that in Notepad, and what I'm going to do is I'm going to within GPT-3, the playground, I'm going to put back those keywords as if the AI had just extracted them, where we say pull out every keyword as the prompt, and we're going to pretend that GPT-3 has just pulled out all those keywords, and then I'm going to add a secondary prompt, so as if we're having some sort of conversation with the artificial intelligence. Just got the wrong prompt there. We're going to run a prompt that says, for every keyword you've identified, return a set of object role modeling fact type readings. So now we want to get fact types out of our text for each as they are found in the text. So we're going to get fact type readings extracted automatically from the text. Use a format similar to person has first name. Make sure that you cover every keyword. Use the appropriate predicate and don't explain yourself. Include implied fact type readings. So I'm going to hit go on that. And GPT-3 should go away and pull out a whole bunch of fact type readings for the keywords that it's identified. So I'll just give that a bit of time to come back, and I'll pause the video for a second. So GPT-3 has come back and returned a whole bunch of fact type readings for our keywords. Now, what I'm going to do is reduce the amount of text we're working with, and let's say it worked from the top. I'm just going to try and reduce some text so that we can find more fact types. So I'm being as pragmatic as I can here, and I'm going to say find more fact type readings please, and hopefully GPT-3 will go away and find a few more fact type readings for it. Great, so it's found more fact type readings. That might do us. So what I'm going to do now is I'm going to load these fact type readings to create fact types inside Boston. Now generally we should have a 100% success rate in this, because we've already loaded our keywords into Boston. So if we go back to Boston and inside the Fact Engine Knowledge Language Uploader, what we've got there is a whole bunch of knowledge language statements. I'm just going to tidy up some that are clearly going to fail, and we should now be able to load these directly into the model as fact types. So you can see the Fact Engine Knowledge Language Uploader stepping through those as it creates fact types inside Boston and inside our telephony model. So just to recap where we are, what we've done is we've taken a document, we've gone to GPT-3 in its playground, and through a series of prompts we've extracted keywords as object types, and we've extracted a whole bunch of fact types, and now we're going to load those into Boston as object types and fact types using the Knowledge Language Uploader. Now the idea of this exercise is that once this information is inside Boston, we can work inside Boston to shore up our model and delete or modify those parts which we're not happy with. So I've got an error there. A fact type with this predicate already exists, so we don't need to do that. And I've got some duplicates there, so I'm going to stop there. So now if I go back to the model dictionary and refresh the model dictionary, I don't have any general concepts anymore. I've got a whole bunch of entity types, and they all look not too bad for me. Amos Joel is not an entity type. I'll just have a look inside the diagram spy of Amos Joel. So Amos Joel is a person that worked at Bell Labs. Now, do I have person in here? I don't. So I can just change Amos Joel to person, for instance, and I can change the predicate there to worked at. Now Bell Lab is still a entity type, but I can change Bell Lab to company. I don't have company. So now that I've got my information or my quasi-ontology inside Boston, I can start to flesh it out and we can say make that a many-to-many relationship where person worked at a company. Now I don't understand this particular fact type, so I'm going to delete it altogether. So we've got a fact type that we're more or less happy at. So person worked at company, we can change that to an objectified fact type and say put a start date and an end date on there, and we start to flesh out our model. So let's do that. I'm going to remove that from the page. I'm going to, before I objectify that, I'm going to give person a reference mode. So we're going to identify people by their person ID as the primary reference scheme for person, and company by its company ID. We're going to objectify that fact type, and I'm going to give that fact type a name. I'm going to call that employment, and using the virtual analyst, I'm going to say employment was from date, and I'm going to say date is written as temporal date and time. That'll do for now, and hit go on that. So it's going to create a value type for date and a fact type for employment was from date. I'm going to say that's mandatory. I'm going to put a uniqueness constraint on that. I'm going to set the data type of date to temporal date, and I'm going to create another fact type. Employment was to date. So quite quickly we're fleshing out a model if this is something that we want to store in our telephony model. But let's have a look at more telephony type things. So in our fact types, this one looks interesting. So cellular network has telecommunications network. So I'm going to view that in the diagram SPY, and we might say yes, cellular network is definitely something I want in my telephony ontology or my object role model. I'm going to say that each and every telephony network is identified by its cellular network ID, and let's say a cellular network is part of a larger telecommunications network. We're happy with that. I'm going to give that a reference mode of ID. So telecommunications network is identified by its telecommunications network ID, and we're going to say that a telecommunications network can have multiple cellular networks, and where if we know the cellular network, we definitely store information about the telecommunications network it's in, and using the ORM reading editor, I'm going to change that predicate to cellular network is part of telecommunications network. I'm going to change the fact type to that. So that's how we would quickly create our model inside Boston. So we've created a whole bunch of fact types which we can go and edit and modify, and we can review all of the entity types that have been created and decide whether or not they are appropriate for our model. And I'd say that we've saved hours and hours of time by speeding up the process by engaging with artificial intelligence to do our keyword extraction and using artificial intelligence to identify candidate fact types for our model as well. Now I've identified, for instance, one that we might want to tidy up. We've got a fact type large organisation has fleet, and we probably don't want large organisation as a entity type. We want the one we created earlier, which is company, and I'm going to try and dump company on this model. Not the way to do it by dumping it in the diagrams by. We need to go to an object role model page. So if I drag company over and the fact type large organisation has fleet, for instance, and now I can drag that role to be joined to company, and I can get rid of large organisation altogether. And what I'm going to say is that a fleet is identified by its ID. So we definitely want fleets in our model, and we are going to say that for every fleet it's mandatory that we identify the company that it belongs to. Now, why do we have fleet in our model? Well, let's add to the page things that it's related to, and it's in our model because the fleet has a dispatch. Now, dispatch might be to dispatch a maintenance crew to go and maintain a cell tower or something like that. So I'm going to say, if we know the dispatch, then well, first of all let's give dispatch a reference mode. We'll make it mandatory that if we know the dispatch, then we know the fleet. Now, a fleet has multiple dispatches, and a dispatch is for one fleet, so we're happy with that. So that's how you would do it. So once you've got your model, you can go through your model and check to see that all of the object types that have been identified are ones that you want in your ontology or your conceptual model, and that all your fact types are. And of course, we did things fairly quickly here. What you could also do is vet or go through your keywords before you get a artificial intelligence to identify the fact type readings for those keywords as object types, and that should save you a lot of time in pruning the object role model once it's created. So I just want to add to that before we go that the most professional way to prune your model once you've got a model imported using the Fact Engine Knowledge Language Uploader is to use the error list. And how this helps you considerably is that the object types that have been loaded, so the entity types in this case, all of them when they were loaded they don't have a reference scheme, so they've got no way of uniquely identifying them. And what you would do for each of those is go through and fix those errors. So for instance, you'd select an error that says entity type requires a reference scheme for the entity type cell pattern. I'm going to show it in the model dictionary. It's there in the model dictionary. It automatically opens in the diagram spy, and when we click on that, go to its properties, we can give it a reference mode. Now it's up to you if you give it a compound reference scheme or a simple reference scheme. We'll just give it a simple reference scheme where we're saying cell pattern is uniquely identified by its cell pattern ID, and that's what a reference mode is. I can expand that reference mode to have a look at that. So cell pattern has a cell pattern ID. That's our reference mode. Now because we've fixed that error, if I refresh the error list, it'll no longer be in the error list. So you can do that for each and every one of the entity types that have been created, and the ones that you don't want in the model, you would prune those to get them both out of the model and the error list. Similarly for the fact types, none of the fact types that we created have an internal uniqueness constraint, and that's an error. So we can, for instance, have a look at this one. Cell has frequency. Load that into the show it in the model dictionary. It opens up in the diagram spy, and let's say that cell is a valid entity type, and we give that a reference mode. So we're happy that cell is in our ontology. We give it a reference mode, and let's say that frequency is something that we want in our model, but maybe as a value type. Now I should be able to convert this to a value type in Boston. No, we can go from a value type to an entity type, but not the other way around. So what I'm going to do is say remove that role. Hopefully I can remove frequency from the model, and then I can go to the toolbox and create a just give me 1 second. I'm going to copy that fact type, put it on this page, and then I'm going to go back to the toolbox, create a value type called frequency, because we didn't want frequency to be an entity type, we wanted it to be a value type. And we're going to fix that fact type. And we're going to say frequency we want as a double precision floating numeric number, and a cell, let's say a cell has and we're going to give that a fact type reading. So cell has great. So now we've not only fixed up this fact type so it'll no longer appear in the error list, we've fixed up the entity type by giving it a reference scheme so it no longer appears in the error list. And it becomes gamified then, that if you get rid of all of the errors in the error list, then you know that you have successfully and professionally gone through all of the fact types and entity types that were created to resolve, if you want them in your ontology, and if you do want them in your ontology, how they appear in your ontology. Are they a value type or an entity type? Is the fact type valid? Does it have an internal uniqueness constraint? What is the reference scheme for your entity types? So once again, to professionally resolve the object types and fact types that were imported into the model using the Fact Engine Knowledge Language Uploader, step through the error list and sequentially fix all the errors in the error list, and once you've done that, you know that your ontology is what you want it to be. So thanks for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.